resources, I want to make sure you can access those resources. So there are kind of two ways to follow along. One would be this QR code. If you open this QR code, you'll be seeing the slides and you can along there. Second, if you go to this website and you go to the training resources page, I have a link to the slides there as well. So everything I say, a lot of it will be referencing other materials, and this will give you access to those. So you might want to grab that stuff. Um, Luis, it might also be possible to drop a link to this in the chat.
Yeah,
I
yeah,
don't
yeah,
know.
I'll do that right now. So itemresponsewarehouse.org. I will do that right now.
Perfect. Thank you. Okay. I'm going to talk about a lot of stuff today, and I just want to be really upfront about the fact that this has been a big group effort. There are a lot of people that have put time and energy into this. Several of them are pictured here. I think Li Zhen is even on the call. I'm going to talk a little bit about her research. I'm talking about it, but please know that I'm just the tip of the iceberg. There's a big team that's been absolutely essential in getting this work done, and I've also benefited from the support of both Stanford University and the Jacobs Foundation. Okay, here are the goals for my talk. So my first goal is just to share my enthusiasm for the IRW, and I'll talk to anybody about it. So here's a picture from another talk I gave recently. You all may recognize that group. Um, Along the way, I want to describe the what and the why of the item response warehouse. I want to give you all a sense for why we're building this and what it can do. I then want to give you a few pointers for how to use it. And in particular, my goal is to set you up so that you can go out and begin to experiment with using it to do psychometrics research and analyses. And I'll also, show you how to get help if you need it, because, there are some issues that you might stumble on, and we're here to help with those. And I'm going to spend a lot of the talk going through some research examples to kind of flesh out the kinds of work that we're doing with this and that I think might be illustrative in terms of what other people could start to do. So what is the item response warehouse? It is a collection of over 900 item response data sets. I actually updated the website this morning, and I believe there are now 939. There's over many billions of item responses in there. And there are a few kind of critical features of it. First, all of the data that are on the item response warehouse have been licensed for this kind of reuse, and we provide information about that data such that you can kind of better understand what you're using, how to cite it, and I'll offer more information about that as we go. All of the data sets have been harmonized to meet a data standard, and this is really critical and something I'll talk about at length. If you understand our data standard, you can instantly be working with very large volumes of item response data because everything has been formatted to have that same standardized format. And finally, there are API-based tools for working with these data directly from R or Python. In particular, I'm going to talk about an R package we've developed that really makes it, I think, quite easy to work with this data. So why do I think we need the item response warehouse? The full version of this argument is fleshed out in the paper that I'm showing at the bottom, but the kind of sketch version is as follows. I think psychometrics is an absolutely critical set of tools for many disciplines, and even, for business and medicine and education, right? Not just in the academy, but also in applied settings. And methodological research in this space has been, I think, somewhat constrained by the fact that there are relatively limited data resources. So if you think about the kind of canonical psychometrics paper developing a new method, there'll be a lot of math, right, showing how the statistical model works, maybe some simulations, and then finally application to one single empirical example. And I think this is just subpar because we're immediately going to have a very limited and likely biased view of the performance that method might offer. And in general, I think that the fact that we don't work with large volumes of data it leads us to a scenario where we don't get good signals about what kinds of methods we really need for solving the practical problems that are really abundant. And so it's for these reasons that I've been working on this resource. What is in the IRW? So the IRW, as I noted, is some 900 plus tables. And to be in the item response warehouse, you have to meet our inclusion criteria. These are pretty broad. The core thing is that the data has to consist of cross-classified item responses. So let me kind of walk through what I mean by that. The responses need to be ordinally coded, right? So that, they need to be in categories that can be coherently ordered. And the responses need to be cross-classified such that they are coming from some set of probes that we're using to measure an attribute of something, almost always a person, but it might in some cases be something else, right? So the responses are cross-classified by a probe or an item or a trial and a person. The way we have structured the data is such that the tables generally are such that each row is containing all the information about a single response, and I'll show you what that looks like in just a moment. A few other facts. The data in the item response warehouse are real, not simulated. We're actually beginning a second repository of simulated and synthetic data, but everything in the main IRW is real. We've tried to strike a balance between lumping and splitting. So if we have data from a paper that talks about measuring pandemic-related anxiety and perceived stress, we'll split those into different tables in the IRW. You may not always want such split tables, and we're trying to make ways available such that you can rejoin tables. You can read more about that kind of functionality here. There's really vast heterogeneity in the types of tables. We have educational measures, personality surveys, patient-reported outcomes. It's a very broad array of things, and I'll talk more about how to pick the kinds of things that you want downstream. There are a few edge cases that we're working on that I'm mentioning here to kind of illustrate the limits of our data standard and where we're having to think creatively. One scenario is that when probes are continuously varying, so if you have a mental rotation task and the rotation can be any angle, that doesn't really kind of work with our standard data format. So we're having to figure out how to incorporate that kind of information. Or there are other scenarios where there's now process data being collected so that you have a lot of information about a single item response. Maybe you have a click stream, and that kind of thing can be somewhat challenging, but we're again working on ways of storing and standardizing that kind of information. So here's a picture of the data standard, and there are three essential components. The first is the ID, which is the identifier of the thing being measured. It's typically a person, but not always. The second is the identifier of the probe or the item being used to measure. This is just an ID. It might be numeric, it might be alphanumeric. And finally, we have the response vector. And what's really critical is that we work to ensure that all the responses have been coded such that they can be readily treated by an analyst as just ordinal data. So if responses were, if -9 was used to code missing responses, we've tried to fix that. Those kinds of things we've resolved in our standardization process. You'll note that the data are stored in a kind of long format here, such that each row represents a single response. There are other formats that we could have used. The reason we did this is that it's easier to store additional response level elements that I'll talk about as we go. And one thing that you might want to do is convert to a kind of wide item response matrix where individual cells are the combination of a person responding to a specific item. And we have some functionality that's built out to help you do that easily. Alongside the kind of three critical ingredients, we also have non-response elements that we're trying to preserve and standardize. As a few examples, if response time is included, we always save it in a standardized way. If the chronological time at which the response occurred, we save that in Unix time. And there are many other things that we're saving in standardized formats so that people can write code such that analyses can be done with not just the responses, but these other elements as well. The data standard is really critical. You can read more about it at the page I'm linking to here. And if you understand our data standard, you can quickly begin to analyze large volumes of item response warehouse data. And our goal is to make it such that if you can query the kind of data you need, we're provisioning it to you in a very accessible fashion such that you can quickly start to do methodological research with that data in a very easy for you, it's meant to be a very painless process. Here are a few examples of some IRW tables. This first one is the verbal aggression data that's widely used in psychometrics papers. It just has the three basic elements, right? Just has the item, the ID, and the response, right? So this is a very simple kind of table. Here's a different table. This is a data from a set of luminosity discrimination tasks. What we have here alongside the three core elements, we now also have response time, right? So you can see how response time has been included, and it's, coded in seconds here. Here's another example where we've added more information. We have the wave of data collection, and then in particular we have treatment status. So this is data from an RCT that was done where there's a psychometric outcome being used to evaluate the efficacy of the RCT. And I'm going to talk a lot about this data today, and this is something that my collaborator Josh Gilbert has helped put together. So you can see here a variety of different types of tables that the IRW is including. One question you might ask is, where does this data come from? My short answer is that we're data pirates. We're using whatever we can kind of scrounge up. I have a set of journals that, every time a new table of content comes out, I go through those articles and see what might be useful. I've spent hours searching through the OSF and Dataverse websites, picking data sets that might be that might meet our inclusion criteria. I've gotten data sets from common software, that are used in psychometrics. And it's important to realize the IRW is a great big convenience sample, but my goal is to make it as big a convenience sample as possible so that no matter what kind of work you want to do, you'll be able to do it with the IRW. One important caveat is that while we are data pirates, we're ethical pirates. We've really worked hard to only use data that are licensed for this kind of reuse. And in particular, we're making all of the license info for the IRW data sets available such that you can kind of know more about the licenses that are applied to those data sets. I think the licensing is really important. We've worked hard to respect licenses, and we're happy to remove any data that people don't want us to have on the IRW. And one last point on licensing that I would like to make is that it's really useful when people license their data. Licensing tells others what they can do with your data, and if you have a license applied, that answers the question. If data sets are posted without a license, it's just unclear. For me, it means I have to email them and ask. If you're curious about licenses, I think these Creative Commons licenses that are shown here are really very straightforward, very useful. And so, from my perspective, really helpful when people license their data. I've noted a bunch that the data in the IRW have been standardized. And I wanted to just kind of make some notes about this process that we worked through. So how were the data standardized? And the short answer is that it's just been a huge amount of work, just many hours by many people to get all of the data sets such that they meet our standard. And I'm trying to emphasize that this was, large amount of human effort went into this standardization, but now you as a user can hopefully really benefit from that effort that we put in. If you're interested in how this has worked, we've tried to really document a lot of the standardization process in various GitHub issues. And we've also made all the codes used for harmonization publicly available. So if you go to this link here, you can find all the code used to harmonize the various IRW tables. We think it's really important that we make this code available so that people can check our work. They may also want to create, slightly different versions of the data, and they can do that fairly easily given that we have code available for them. And you can also create IRW compliant versions of private data sets that can't be publicly reshared. We have code that would allow you to do it for some common data sets, but you could also imagine doing this on your own. We'll talk at the end about how one could contribute to the IRW, but I'll just say up front, we welcome contributions. We're always looking for data. I'll tell you more about this later, but yeah, please do know if you have data, we are anxious to get our hands on it. So how does one work with the IRW data? There are a bunch of different forms of working with the IRW data. I'm going to talk through some of them. And what will be useful is if you have a better sense of the architecture of this platform before I tell you the specifics. And so the platform is kind of formatted as follows. The IRW data live on the Rediviz website system. Rediviz is a data management system that's really convenient for us. It has version control, supports API calls, and allows direct access with Jupyter Notebook so that you can kind of you can work directly on that site in a very easy way if you want to do that to access the data. So that's where the data live. We also have a website that is integrated with the Rediviz system. So our website has some capacity to interact with the Rediviz functionality, also contains information about the data standard and other kinds of similar things. And finally, there's an IRWR package that we've designed to make it really easy to work with IRW data directly in R. I think for most people that work in R, it's really going to be the best way of working with IRW data in research. There are a few small startup costs that I'll mention. Mainly you have to authenticate, and that can be a little bit of a hiccup. But once you figure that out, it is, I think, a really streamlined way of working with the IRW data. So to walk through usage of the IRW data, I'm going to make a few points along these lines. I'm first going to talk a little more about the data standard. I'm then going to offer several example analyses that you could use at your own leisure. And finally, I'll talk a little bit about how to work with data at scale. So I'll talk about how the IRW package supports this and how to query the IRW tables so that you can get what you like. The IRW data standard is really the kind of anchor that you're going to have to kind of tie all work with IRW tables to, right? So understanding that data standard is really critical. One thing that I think is useful is we're offering functionality that allows you to simulate IRW compliant data sets so that you can figure out how they might work in your workflow before you even begin to access IRW data. So I think that's a useful thing to know about. If you want to start doing some analyses, we have a lot of examples that you can draw from. So on the website, there's a bunch of examples on our Getting Started page. These do all kinds of different things. One thing they do is include calculation of the IMV, which I'll talk about later. This is an approach to understanding prediction quality that I'm really excited about. There are several examples embedded in this training that I gave a few months ago. In particular, this first example here does some basic Roche analysis of data from an author recognition test. There are many examples of different kinds of analyses available at this link that are on Rediviz using Jupyter notebooks, and they're something that you can use straight away if the Rediviz authentication process is proving challenging. And just for you all, I put together a simple analysis with data from the NM assessment, which I think is a fantastic data resource. And so if you want to experiment with some basic analysis of the NM data, you can use this last link. And most importantly, I really want this to work for people. So if you're having problems, please let me know, right? If something is not working for you, I'd love to hear about it. Maybe I can help you figure it out. You can reach out to me at this email address or at any of the others that you can find for me. But please don't be afraid to let me know if there's something that's not working. The most challenging part of working with the IRW data is typically the fact that you have to do some quality control work to make sure that you're getting the kinds of tables that are useful for your analytic pipeline. We have 900 tables, they're pretty heterogeneous, and so you need to kind of do some filtering. Some considerations that you might want to have in mind as you start thinking about IRW tables. First, in some cases, we have repeated observations, right? So an assessment is maybe giving, or a measure is given at multiple time points. One thing that you could sometimes do is just use the first wave and exclude latter ones, but this might be something one wants to think about. Another issue is that there's missingness with respect to the responses that a person might supply to an item. In some cases, we have very sparse item response tables. In other cases, we have very dense item response tables and even multiple attempts. And this issue of the density of item responses is something that one needs to manage to apply many kind of standardized tools. You're also going to want to make sure you have the right number of people and items. To use the NM for an example, there is such a large number of people available there, it might choke many common statistical algorithms, and so you might want to limit how many people you're using. So that's something that one would need to think about. And then the number of response categories is likely to be germane for many kind of psychometrics applications. In particular, we're currently working on one known problem where NA values are somewhat complicating our lives in terms of the way that we're storing the information about the number of categories that responses are reported in. So I'll come back to this in a moment, but these considerations are some of the types of things you might want to think about. But the other thing I want to kind of emphasize again, if you want to do research with this data and you have a sense for what kind of data you want, please just reach out to me. I have a lot of code snippets that I can share that might be useful. I'm more than happy to converse about how to help you get the right data that you need for your work. And I have, at this point, a decent bit of experience trying to pull those kinds of tables. So please feel free to avail yourself of that assistance if you'd like. The IRW R package is really, I think, going to simplify the process of working with this kind of data. There are a lot of things you can do with it, and what I want to emphasize here is that you can first filter on IRW data sets, so you can get the right kinds of data sets for your purposes, right? You can filter based on the number of response categories, the number of items, those kinds of things. Once you've filtered to the tables you want, you can then fetch them directly from the IRW package using a very simple command that just takes a vector of table names and downloads all of them from the Redivist site. This package will also translate the data from long to wide. So when you want to, say, run an IRT model or something like that, it's very easy to then do that kind of thing. And there are a bunch of other helper functions that we're building into the IRW package. One really important one is that you can generate citations for the data that you're using with the IRW package in a way that's quite valuable. And I'll talk more about citation downstream, but I think it is really important that if you use tables from the IRW that you also cite them. And this package has really been developed by my collaborator Hansel Lee. One known hiccup associated with working with this package is that authentication on Redivist can somewhat be an issue. We're trying to get that worked out, but if you have a problem authenticating, let me know and know that this might be a known problem that we're working on. The IRW tables have metadata associated with them, and this has really been something that my colleagues Severe and Adela and I have worked on. And there are two types of metadata that are available to help you filter through the IRW tables. One type of metadata is quantitative metadata, and this is information we're deriving from the tables themselves. So how many items are there in this table? How many responses, right? The number of rows. What is the relative rate of missingness for item responses? These things and others are an important element that one would use to determine which IRW tables you want to work with. We also have done a lot of hand annotation of the IRW tables to basically give you information about the measures and the samples being used to generate the data that might be important. So for example, if you only want to work with data from children, we've tried to make that available. If you only want to work with cognitive constructs, we've tried to provide that kind of information. And so these types of metadata are really valuable for filtering and can be used with this IRW filter function to simplify the querying of the tables that you'd like to work with. All right, I'm now going to pivot to talking about some research examples. The research examples are a subset of the papers shown here on the right, and I'm going to move very quickly through these. My goal is to highlight places that you might want to further investigate. I want to kind of give a broad survey of the landscape, and then you might want to dive deeper on specific things that you're interested in. It is going to be quick, but the upside is that I'm only going to focus on projects where we have a paper available, so you can always supplement the kind of brief discussion I'm going to get here with more comprehensive reading. So the first example I want to give comes from Lijun Zhang, who's my collaborator at Stanford. And this is based off the following observation. A lot of work in psychometrics involves simulations. And what we learn from those simulations is often sensitive to how we configure parameters. And in particular, difficulties in the item response theory kind of sense or intercepts in a kind of factor analysis kind of sense are frequently assumed to have some standard normal distribution or something like that, right? There's some assumption made about how those distributions, how those difficulties are distributed. And what we wanted to analyze was how they actually look empirically. We did this across I think 70 odd IRW data sets. And the punchline is that the distributions of the difficulties in the IRW vary quite a lot. And this is really important because these differences have really big implications for the associated level of measurement precision that one gets from from these different distributions. So, this blue curve here suggests, that we have one kind of stylized type of measurement error. Whereas if we have a very different kind of empirical distribution of difficulties associated with one of these red lines, the relative measurement error at different levels of ability is really quite drastically different. And we think this is a difference worth accounting for. And so in particular, we are now making tools available so that you can harness this kind of empirical variation that exists in these difficulty distributions when you do more simulation work. So our goal is to basically allow you to utilize our observation of this kind of widely varying set of difficulty distributions when you do future simulation studies, so that those studies will more capture the kinds of variation we observe in the wild. I'm going to pivot now to talking about some work we've done on model fit. And it's actually not quite model fit that we're going to talk about. We're really going to be interested in the question of how well do different models predict new data. So we're interested in kind of out of sample prediction that I think is both related to and yet quite distinct from traditional questions of model fit. And the first work I did was with a former student, Ben Stendhaug, as described in this paper. And we've kind of kept going on this path, and I think we have some very interesting results. In particular, I want to talk a little bit about a paper that came out last summer that uses 89 data sets from the IRW, where you have dichotomously coded responses, and we're looking at applications of different IRT models to predict responses from these data sets. Now, here's the part I'm really excited about. To understand prediction across these different data sets, we use this metric that we've been working on for a few years, known as the IMV. This has been a collaboration with Charles Rahal, who's a demographer at Oxford. And the IMV is a metric of difference between two different predictive systems. And the game we're playing is as follows, right? We ask about a scenario where you are a bettor and you're putting down a $1 on an outcome, right? And the first predictive system is used to compute the odds. So, this is basically used to make things fair, such that under this system, your $1 bet is perfectly even. You don't expect to lose or gain money based on the outcomes generated by that first predictive system. The question is then, if the second system is actually generating outcomes, and only you know that, do you stand to gain, right? Do you stand to make money from the information encoded in that second predictive system? And if the second predictive system is better, then you're going to expect to make additional money on your $1 bet, given that you have better predictions from the second system than the first. As one example, in some simulation work we did, when we go from the 1PL to the 2PL, right? So we're generating data from the 2PL where we have variations in item discriminations, and we're fitting both the 1PL and the 2PL to that data. The improvement in fit associated with fitting the correct model, the 2PL, is about 0.01, right? And so this is like saying that you're expecting to make a penny, 1/100th of a dollar for every kind of for every outcome in this betting scenario that we've envisioned. In this context, I'm always going to be talking about out of sample predictions, right? So that the idea here is that the predictions are based on data that the model did not see, and that's really important. And the IMV is fundamentally designed such that it's portable across outcomes. In these 89 data sets, sometimes you have very easy tasks on average, sometimes you have very difficult tasks on average, and it can be difficult to compare predictions across those outcomes when you have very different prevalences, but the IRW is designed to be portable in this sense. This is something that we talk a great deal about in this paper. If any of this is interesting, we have a lot of code resources that you can look at here. But let me tell you about how this worked in our psychometric analysis. When we looked at the 89 data sets, we saw in general that going from the 1PL to the 2PL, right, so fitting a more sophisticated model, really did add a fair bit of predictive value. The average was in the neighborhood of what we saw in simulation. I went to the results for this paper and pulled all of our results for the NM data. And when we predict responses from the NM, based on the 1 PL versus the 2 PL, we see an IMV about nearly 0.01, right? So roughly what we saw in simulation from the previous slide, which suggests that, that there is kind of really substantial variation in the item discriminations in the NM data writ large. However, when we go from the 2 PL to 3 PL, so we're adding a parameter, we really see much less gain in terms of prediction quality. It's really pretty minimal, both in general. These red dots are very near the kind of vertical line. It's true with the NM data. And it actually turns out to be true even when the 3 PL is used to generate the data. So even when the 3 PL generates the data, you get effectively exchangeable predictions from the 2 PL and the 3 PL. And this is something we talk about at length in the paper. We also fit multidimensional IRT models to all these data sets, and there are some occasions, largely personality data sets, where you have real value coming from multidimensional IRT models being deployed, but in general, they're not so useful. And in the in the NM data in particular, multidimensionality did not really account for, it didn't offer much kind of additional predictive power. So the punchline here is that more complex models may not always be helpful, and I think considerations of out-of-sample prediction can be really useful for understanding when that might be the case. I want to now talk a little bit about psychometric outcomes as endpoints in randomized controlled trials. So randomized controlled trials, RCTs, are really critical tools for understanding the efficacy of interventions in education, medicine, public health, all kinds of settings. And in many cases, we have psychometric outcomes that are the thing being used to evaluate the efficacy of the intervention. The observation that we started with in this first paper here is that there may be variation in the degree to which the parts of a psychometric measure are affected by treatment. So to put it another way, items in the outcome may be differentially sensitive to treatment, and we might want to be more sensitive to that. And so we started this project using data from 15 educational RCTs contributed by the REAP and JPAL consortiums. And what we saw is that there's really pronounced evidence that there is this kind of treatment-related heterogeneity where some items do seem much more sensitive to treatment. And so this got us wondering, how should we think about this heterogeneity? What can we learn from it? And I want to provide several notes on this point. This first paper, this was led by Ashita Ahmad, who's graduating here at Stanford. The rest of this work has been taken over by Josh Gilbert, who's a grad student at Harvard. And I'm going to talk mostly about this paper, which is in press now at the Journal of Policy Analysis and Management. So Josh has gotten, I think now exactly 100 psychometric data sets in the IRW that are based on RCTs. And in these data, we observe ample heterogeneity in the treatment sensitivity of individual items. So for every line here, we're talking about an outcome from an RCT, and the individual dots are the degree to which specific items are sensitive to treatment, and the big dot is kind of the overall treatment effect, right? And so you can kind of see, this example here is a case where we have fairly constrained heterogeneity in treatment sensitivity of the items, whereas this example here, has much more pronounced heterogeneity. And we've realized that there are really important implications of this. So one implication of this is that you are going to get fairly inaccurate standard errors for the treatment effect estimate if you're not accounting for the fact that the items may be differentially sensitive to treatment. In some cases, you might be underestimating the standard error on the treatment by 50% or more. So you might be really likely to be making type 2 errors, which would be quite a problem. If you are correcting for the fact that you have items which are differentially sensitive to treatment, as we advocate for in this paper, you're also able to get correct effect size estimates, which I think is a pretty valuable thing as well. Another thing that we've thought a lot about is how this is implicated in the studies of heterogeneous treatment effects. So heterogeneous treatment effects are of massive interest. I did a quick Google Scholar search today, and there have been over 20,000 publications just in the last, 18 months looking at heterogeneous treatment effects. People are really interested in the idea that, when we intervene in education or biomedicine, people may be differentially susceptible to the treatment, and it'd be really useful to identify that so that we could improve the intervention, who we're applying it to, those kinds of things. But what we have realized is that you have to be quite careful when treatment effects are being determined by psychometric outcomes. So here's an example where we have heterogeneous treatment effects in both of these panels. And the issue is that they're driven by two totally different processes. On the left here, we have a scenario wherein people are differentially susceptible to treatment. And on the right, we have a scenario wherein items are differentially susceptible to treatment. And yet, if you're analyzing things based just on some aggregated outcome, right, a sum score, some kind of estimate from an IRT or factor analysis model, that kind of aggregate data is not going to let you identify whether the heterogeneity is at the person or the item level. And we think this is really quite important. It's just very different, say, to have an intervention, to use an education example, that is most effective for, say, low ability readers versus an intervention that is most effective for more difficult items. Those are two very different statements. And if you're only analyzing aggregates, you can't distinguish between them. And with the 100 data sets, we're able to show that this is a problem that occurs fairly often. In particular, the key issue is whether item level sensitivity to treatment is correlated with item difficulty. When that occurs, you're likely to have this type of problem. And our results are kind of lining up nicely between theory and what we're actually observing. And just in general, we think that this suggests that when you have psychometric outcomes as the endpoints of RCT, heterogeneous treatment effect studies are going to need to be kind of made with great care. And in particular, you need the item level data, not aggregate level data, to really make sense of what kinds of heterogeneity you might have in treatment effects. Another thing that we've done with these RCTs, and this is covered in a paper that just came out last week in Psych Methods, has to do with the idea of psychological networks. So let's suppose we're talking about depression indicators. The standard view would be that there's some latent variable causing different indicators, right? So you have both loss of appetite and sleeplessness as two depression symptoms that are both being caused by some underlying sense of depression. In the network view, the indicators themselves are interconnected, right? So it's not that depression is causing loss of appetite and separately causing sleeplessness. It's that you may not have an appetite for some reason and that may be causing sleeplessness. Right, the indicators themselves are networked. So this model suggests two particular features, right? One feature is network strength, which relates to how frequently symptoms are endorsed. Another relates to network state, which is basically the level of connection between the symptoms or the indicators. And Josh's observation is that the treatment could change either the network state or strength. Right? And understanding these as different independent things might be quite valuable. So to continue to talk about the kind of the way this works with RCTs, I want to give you a little bit of an example here with a vocabulary test, right? So this is a vocabulary test that we really focus on in this paper. And what Josh shows is that the intervention did not really help students know more words per se. So a student was not more or less likely after the intervention to understand the word fossil, for example. But what happened after the intervention is that after the intervention, if they understood fossil, they were much more likely to know connected words like paleontologist, right? So this was an example wherein we're not kind of necessarily changing the overall strength of the network, we're just changing its state. And in particular, in this case, this finding is very consistent with the nature of the intervention, where the whole point of the intervention was kind of building connective tissue between words, given various educational nudges that are embedded in the intervention. In the paper, what Josh shows is that treatment effects may occur on both the strength or the state side, and these effects are quite uncorrelated. And so we think it's worth kind of considering, both of these, when you're thinking about RCTs and psychometric outcomes, in particular, all of the things we've considered here in looking at Josh's work are, in my mind, very low cost things we could do with data from RCTs that would really increase our understanding of the nature of the treatment and what it's actually doing. All right, let me now turn to the final example I'll give on the research side. People often describe psychometric data as either ordinal or nominal, and I've always wondered whether this is really appropriately thought of as a dichotomy. Should we think about data as ordinal or nominal, or rather are those poles that kind of mark a continuum, and data may fall at some point in the middle? And so in this paper, we explore a range of metrics that one could use to assess whether polytomous responses have characteristics that are associated with more and less order. And we first probed the functioning of these metrics via a variety of simulation studies. After those simulation studies, we have two metrics that we're really interested in. This one on the y-axis, it is related to the slope parameters from application of a nominal response model. And in the x-axis, we have another index that is related to the estimated probabilities of this ratio under certain assumptions about the levels. I'm trying to offer a little bit of meaning to these things, but this is where looking at the full paper might be valuable. What I want to emphasize here is that when we apply these metrics to a large volume of polytomous responses, these indices suggest that there's really a lot of variation, that what looks like ordinal data may really vary quite dramatically. In all of these cases, we have kind of putatively ordinal values, and yet, as you can kind of see just from the variation on either the x or the y-axis, we have really striking levels of variation such that data over here are really much more ordinal than data over here, and that is entirely kind of masked if we just think about these as all ordinal data. Okay, I want to begin to wrap things up. After this talk, you're going to have the same feeling as these folks. You're going to be incredibly excited about the IRW, and what I want to give you is a few notes about what to do next. Also, my colleague Guilherme, who some of you may know, he was furious that the AI put 19s on both jerseys here, but you can talk to OpenAI about that, I guess. Okay, so if you want to use the IRW, a few things. First, I'd love any feedback on how to improve it. We're always looking to make it more usable, and so if you have ideas, please let me know. If you use it, a few requests. First and most importantly, please cite the data you used. We've worked hard to make this easy and want the original authors to get credit. My concern is that if people don't get credit when other researchers are using their data, they're not going to want to include it. And so we've built functionality that allows you to easily generate citations. We have that functionality both on the website and in the R package. It's really important, I think, that you cite the data and let us know how we can make that easier, but that would be my main thing. That's why it's in red. If you want, and it's appropriate, you can also feel free to cite our manuscript, but that's much less important. We're always looking for ways to both improve the IRW in general, and then specifically with respect to data. If you think you have data that could be added, we have a page that describes what you could do. You could contact me, and I'll also point out that my collaborator Joao built a really nice tool that simplifies data processing, such that if you have data that's in a relatively standard format, you can likely run it through this tool to get it into the IRW data standard, and that might simplify adding that kind of data. If you have code that's useful for working with IRW data, I'd love to see it. If you want to get involved, let me know. And like I said in the last slide, if you have ideas for improvements, please send them our way. I'm going to stop there after making a few final notes. Thank you a ton for having me. This was really fun. I'm excited to talk about it, especially with a non-American audience. I have grand plans to do more trainings in more languages using the language skills of my collaborators. So one day, hopefully this will be done in Portuguese by Joao or somebody else. Here are a few critical links that you might want to use, and then two very brief final asides. I run a psychometric seminar at Stanford that's done virtually a couple of times a year. I love the idea of using Zoom to make this kind of thing possible. So if you're interested in that, please sign up. Second, and lastly, I worked on a paper with a former student, Clint Konopka, that used NM data, and I thought some of you might be interested in that, so I wanted to shout it out here. So I will stop there. Thank you so much for having me, and I hope we have a few minutes for questions.
Whoa, I'm impressed. I'm looking at the data warehouse right now. I think you have more than, I don't know, like 500 data sets here, right? Let me share my screen.
It's more than 900.
So, can you see my screen right now?
Yes.
It's like impressive.
There's a lot of data.
Oh, yeah. So let me start sharing. I don't know if someone has some questions to Dr. Ben. I do have like 5. So anyone, does anyone have questions? So okay, while people are just write down questions, I have like 2 main questions for you. The first one, maybe I know the answer, but I was thinking about to the data warehouse, like risks. Let's say I have a data frame and send that to you, and now the data frame is available, and one guy just get my data and check the results and see some minor difference that happens all the time. All the time. I'm using my data frame to teach psychometrics, and all the times I make like little mistakes. Then that makes a nightmare for me because that guy or that, that colleague gets my data and with the editor. So my first question for you is that possible, this environment to happen? Or do you think that's like not possible? Or did you get that right?
Yeah, I mean, I guess like my understanding of that issue is that uh, so
Like
for example, if
the
you
data colada thing, do you remember the data
yeah,
colada thing?
yeah, of course. I mean, I think anytime you have, one is doing open science and making data available, there's this possibility that you might get uh, that you may have made a mistake and that somebody else could catch it. I think in general, uh, that's possible when you have data that's posted publicly, and since the vast majority of the data that we're working with has already been posted publicly somewhere else, I don't, in my view, we're not really greatly increasing the risk, but I take your point. I guess my hope is that, ultimately, to the extent that, this makes it easier to replicate what people do, it results in higher quality science. But I think you're right that there is just it is just kind of scary to release code and data because other people may catch you.
Yeah, actually, all the time I teach my students to use open science framework because that's the way we do science here at my lab.
Yep.
However, all the time when I'm teaching, like several years later, I I realized some mistakes were, under the radar. All like not big mistakes, but some, like tricky
Yep.
things like decimals and things like that. And I'm so
Inglês?
so Renato has a question for
Não, tá
you.
muito baixo.
This is that.
Yeah.
Can you
So
see the chat?
yeah, I'm looking at it. I think this is a great question. What I would say is that we've designed these metrics so that one could use them to actually better understand the relative degree of, uh, that you could actually understand where on that spectrum your data may fall, and you could assess, do these seem like they're highly ordinal or much more nominal? And so if you look at the paper, the indices I think would be my main recommendation in terms of what steps you can take to really not just avoid the issue but understand it. If you compute the indices that we show there and the results suggest that these are pretty ordinal, then I think there's one class of models that are appropriate. If, on the other hand, you compute the indices and these data look quite nominal, then you might want to use a different class of models or consider whether there's some coding error or ambiguity that could be resolved. But I think, yeah, starting with the indices would be my main suggestion. But I think this is a great question.
Yes, and I do have like 2 more questions for you. The first one, I think you told that before, like citations, because all the time people can get the data and use the data, and I don't know if that's related to citations. I don't know, if it's by default, if I make my data frame available, people will use and cite me. I don't believe so. That doesn't bother me. but I know that's a reality, right?
Yeah. I mean, I think I have mixed views about this. I mean, I think on the one hand, it's really important that people can cite the things they use, and so we've tried to make functionality available such that it's really easy to cite the data sets you're using. You can use 50 data sets from the RW, and you can very quickly output the 50 kind of BibTeX citations, and like I think that really helps to allow people to cite the data they use. On the other hand, I think it's really important that psychometrics become a more data rich discipline, and I don't want arguments about citations to be the limiting thing there. And so I think people are also going to need to be a little bit more, um, forgiving about the fact that citations are difficult to manage in some cases, and it's mistake possible. And so I think we're going to need to just like be able to grow into a more data rich discipline use with some degree of kind of efforts being made both to cite things that people are using, but also understanding that that can be a difficult thing to do, but that what really matters is doing things in a more data rich fashion, in my view.
I agree. And actually, I have just a last question for you. It's very collateral question, because, I'm a professor here at the Catholic University, and I have an affiliation with the University of Oregon. And my role here is undergrad and grad, and I have a lot of master and PhD students. But being honest to you, I never had the time to teach them about that. It's so high level, I was talking to a student while you were talking. It's so high level because it includes modeling, item response theory, R, Python, websites, data, sharing data, open science framework. So, and I know you have family. So where do you find time to
Well, so I mean, I talked to the beginning about the fact that there's been a big team involved, and they're really, a lot of what has happened is not stuff I could have done. Like, so the website was designed by Mika Brzezinski, who's a collaborator here at Stanford. I could design the website. The R package was written by Hansel Lee. So there's just a real effort, uh, and a lot of people have contributed. My goal ultimately is to make this a resource that is kind of for a community and owned by the community. And I don't totally know how to do that, but in the long run, I'd like this to be something that is not mine as much as it is a community resource. And well, to the extent that people have ideas about how to do that, I'm all ears. But the only way this could have been done was just through the help of a large number of people. And a lot of time, I've a lot of nights on the couch on my kids watching dumb TV, just going through journal articles, finding data sets. So some of that too.
got that? And of course, I have some grants that you can work with, right? In the United
Yeah.
States, to manage that because sometimes it's very hard to work on that without grants.
Yep.
So I'm impressed. I don't know if someone has more questions. Anyone? Renato? Valkyria? Rodrigo. Actually, Rodrigo was my former PhD student, so he'll have a message for you here. Can you check that?
Wonderful. Yeah. So you could definitely do a lot like looking at reliabilities of different kinds of measures. This is where you have to do some QC work. So for example, if you just want to um, compute, Chromebox alpha or something, you're going to need to subset down to the kinds of data that allow for that. A lot of when you have multiple waves of data, that can be a little bit of a challenge. So I think you're absolutely right that there's a lot of things you could do with this. The biggest challenge, as I mentioned, is just the kind of filtering down to the right number of tables. But once you've done that, then I think you can do any number of things. Um, Absolutely. I think you're muted.
Está mutado.
Oh, sorry. Yeah, actually, sorry, my bad. So, no more questions. I'm really impressed. And I hope I can see you while I'm in the United States. I'll be there in like 2 weeks from now. I know Oregon and California are very close. However, it's like 5 hours by car, I guess.
Well, I would welcome that, and would, yeah, if you're ever in the Bay Area, please let me know, and I'll definitely let you know if I'm up in Oregon.
Rio, how about that?
Perfect.
So it was a pleasure to meet you here. Thank you so much again. And let's keep talking.
Absolutely, and yeah, feel free to reach out to me. Anybody on the call that wants to send me an email, you're more than welcome. I would love to hear about your experience working with our resource, and I'd love any suggestions for improvement.
Okay. Thank you so much and have a good one there.
Thank you all. Bye.
Bye.